Good morning. As the truck goes by. Yes, this is going to be a physicsy video. Good morning, everybody. Happy New Year, and all that kind of stuff. Though I'm an empirical based person, so the solstice is my day of celebration. You know, I like to keep it the solstice season, which marks the new solar year. Anyways, let's do a video. And we're going to talk about how mass evolves from mass-free space. Because along with this video, I will post a article that talks about how there's been modeling done, and just from Brownian motion, randomized motion in fluids, how vortices form as a way of um, conserving momentum. Yes. How does conserve energy actually? Like a vortex is actually a good way, because just a slight curve in your path means that now you have an endless path of no collisions, right? Because you're going around. This is the beauty of being in orbit, is you're not going to bump into so many things, sort of, is the plan. Anyways, so this is random space. Just random mass-free space. Okay, but we're going to pretend like gravity already exists. Gravity is just the most fundamental force. So we have mass-free space, and then what happens is, just as if this was a fluid or a superfluid, any perturbation in the density, like we have to imagine this is all even, and then somehow someplace gets a little energy. But gravity means that if there's some energy someplace, the surrounding energy that's not as strong as that energy will start to move towards that energy. And then before you know it, you just have all the energy from everywhere trying to rush into the same place. And you can't, so to preserve, this is exactly what happens basically, is that everything's trying to get there. If you collide in the middle, then there's a bunch of friction here, and it's very, very like bad for your energy, because there's a bunch of collision. So what's instead a smooth operation is to form a vortex. And this is what I think mass-free space does. It forms a vortex, and it forms a minimal singularity right there. And because this minimal singularity is a true singularity, it's a perforation in space-time, that literally the mass-free space falls out from here. It goes into the antimatter world, or maybe it goes into the Marangoni current. I'm still debating my middle space structure, because I'm thinking more and more that it's a double layer is the thing. The universe is like a double layer. There's us, and there's antimatter, or us and antimatter, however you put it. And okay, so this vortex is coming this way, right? It could shoot out on the other side and be an outflow. But in terms of mass, how does that work? That doesn't work. But if you have them still, on the other side is the complete inverse, so that's why it's antimatter, is that the curl is inverted. It would look just like this, but because it's on the other side, it would actually be an inverted flow, which would mimic this flow and yet be on the mirror side of inequalities. But then they would both just hit this middle zone, which is the actual surface of time. That's what I'm talking about. There we go. Right, and everything's being drawn towards that. surface of time. That's what gravity is. And this surface of time sort of emerges as little bubbles where it can as neutrons in deepest void. Anyways, so yes, so we have a perforation, so we have an outflow. Because there's an outflow, that means there has to be a compensatory flow in here. Otherwise, you just run out of everything. Right? And in my model, basically, this was the mass is caused by this angular momentum in rotation, because, as I like to point out, I just use classical mechanics. E equals mc squared is a quick one, so we'll do the quick one of this one, which is m equals E over c squared. Mass is energy in orbit over a Planck at c, right? Because everything's moving at the speed of light. But that gives us the angular momentum of c squared. And there is the classical derivation of math. So there we have the mass part, is this resistance of this vortice to be moved, because it's got a good place. It's happy where it is. Don't move it. It's got angular momentum in every single direction as this vortice. This is a 3D vortice, right? This looks 2D, but it would be a 3D vortice. So, anyways, so now we have a minimal singularity. Now we've got, and now if we have a dielectric fluid, the flow, this flow into this singularity, into this hole in space-time, if this was a dielectric, flows in a dielectric fluid create charge separation. This is like a physics thing that we find in all condensed matter, and I would suggest applying it to all matter. And what it is, it's just charge is like a measure of the stress tensor of this pulling. It moved that far in that moment, let's just say, right? And this was moving there. So sort of the lag, the tug, because this is an acceleration. This is going faster than this point. It's going faster than this point. It's going faster than this point. It's going faster than this point. There's a constant mild tug on space towards this singularity. And that tug is negative, the negative charge to the electron field, because this actual place where it all finally condenses, the surface of this singularity, is the actual convergence point, and that's why protons are localized and electrons not so much. Yes. So that there now we have a hydrogen atom that just formed out of space, right? Just from space-time collapsing because of gravity, just space collapsing because of gravity created a vortice, which now has mass and a charge around it, a charge pair, and one of them, the positive, with mass. Now, let's scale this up. Now that we have a whole bunch of things that can carry charge on both sides, so they can sort of like balance off charge to a degree. Now let me just perform the same principle at the next scale up. We have a bunch of amorphous space, but of course what happens is you end up getting galaxies, boop, and vortices that have singularity. And what happens at the singularity? This is where there's a perforation. And we're going to imagine a hydrogen atom, even though almost all the hydrogen in the universe ends up getting turned into some other element long before it gets to anywhere near singularity. Right? Most of the matter gets turned into, the hydrogen ends up fusing into helium, into everything, slowly over various processes. Getting heavier and heavier generally overall. So it's rare that you would have a hydrogen atom. But let's just pretend. What even happens? Here's the proton. Here's the field. But what happens is, even if this was only a neutron star, right? Why is this a neutron star? Well, that's because any hydrogen, anything that comes this close to the neutron star, this neutron star has so much gravity that what it's going to do is this going to push, literally scrunch up this electron and shove it back into the proton to turn it into a neutron. That's how strong the gravity is at a neutron star. Okay, so therefore, this gravitational intensity must exist at not just on a neutron star, but at a black hole, which is more dense. This must be an intermediary stage between there and the black hole. So if you're coming across a black hole, this is now a black hole, right? You are going to be turned into a neutron at some point. Just a neutron. You don't get to be you're a proton electron complex, but then you get scrunched up and then you're a neutron. And not only that, then you become neutronium, which is where the neutron sort of, when you become a black hole, is when this neutron touches this double membrane, and it's a double membrane, it sort of joins with it and just becomes part of the flow. Is my premise. That this is like a double layer lipid membrane. This is a double layer lipid membrane. When they join, they can join completely. And the vacuole, which was inside here, which is nothing at all, falls in there. So the neutron falls in, hits the event horizon, because it's now a black hole, right? So it hits the event horizon. When it hits the event horizon, that is all there is. There is event horizon. There's no singularity in here. There's nothing past the event horizon. The event horizon is like a membrane skin, because this is at this point where it becomes a neutron, and a little further where there's unity, that's like a phase change. It's the difference of water and air. And it's not that there can't be some Hawking radiation, which is much like evaporation, but there's still a fairly easy to define membrane phase change between these two places, between these two layers. And my proposition is that when a neutron falls in here, what happens is that the neutron curvature, when it joins, it loses all of that curvature. Right? Now it's just flat. And it used to be, look how curvy it used to be. That curviness essentially is the neutron description of the rotational components of the neutron. That it is charged and that it is in a rotation like that. So instead of losing that information, because that's essentially part of the information, the other part is the kinetic energy, the exact approach angle, essentially, of this neutron. That is given to the event horizon. So the history stays with the event horizon to be part of the holographic universe. And then the other component, the sort of the generic soul of the neutron, reemerges in deepest space where there's no pressure at all, where it's the easiest to emerge, preserving the information, but now it's just a blank neutron, which soon decays into a big amorphous piece of super, super cold hydrogen. And I think it's so cold and the electrons are so far apart that actually it just sort of forms an electron field with the protons sort of balancing themselves in sort of like a really, really loose jelly sort of something substance, Rydberg material. Anyways, so this is the premise of neutron decay cosmology. It falls in, it explodes. This is dark matter because if this electron is not properly associated with only one proton, we can't get proper photon reception here because what's it going to absorb? Like, which one is it going to? This is the whole thing. It's a resonant cavity, the proton-electron complex, and therefore the photons that emerge from it or are absorbed by it are all harmonics based upon this quality of the photons, of the proton-electron complex. Neutrons don't even hardly play a part. And yes, so neutron decay cosmology. That was a rambling version, wasn't it? Yes, I think it was. But I think I hit everything. Quantum cyclic cosmology. Quantum cyclic cosmology, that's it. Neutron decay cosmology, same thing. Premise. Hydrogen hits event horizon. Takes an Einstein-Rosen bridge from highest energy pressure conditions. This is the only place you're going to get an Einstein-Rosen bridge. Okay, people thinking that you're going to build a spaceship that can do warping space-time. I just think you know that surface has to have the most insane gravity. Has to, because that's just the way it is. If you have that much energy, enough energy to make an event horizon, that means you're warping space-time, which means you're at the absolute limit. You know, like the absolute limit. We see the artifacts of the damage the tampering with this shit does. Okay, that's what we see. We have no idea what that kind of intensity of like the most intense fusion reaction we've ever seen is just the surface. It's like way out here compared to what it could be. You know, like it's really like people are deluded about we make a few bombs and we think we're like masters of the universe. Anyways, that's my rant portion of the show. So, neutron decay cosmology, quantum cyclic cosmology, new brand. Sorry, I keep on forgetting myself. This is the premise. Peace.